times V out minus VI squared
Okay, say that. Delta KE
equals 1/2 V out squared minus VI squared.
minus VI squared. You didn't have the 1/2 squared with it.
No, I multiplied the whole thing. I have parentheses in there.
Oh, I see. Okay.
Okay. And so once we did that, I just plugged in what we have.
Which was, let's say the same turbine is. And it just let you do it like that, and you got the right thing.
Yeah, and then you just got divide by 1,000 to from meter squared to second squared. You just gotta find the conversion.
Okay, so this is 80. The other one was 50.
You should have negative 1,950 meters squared per second squared.
Say that again.
You should have negative 1,950 meters squared over second squared.
Okay, that's there, isn't it? Yeah, 1,950.
And so the conversion I used for that was watts over joule. So basically, I used 1/1,000 joules.
Yeah, so you just multiply that by, and then that'll give you kilojoules. Right? That's what you meant by that. I'm assuming.
Yeah.
Yeah, that's just 1.5. Yeah, and then kilojoules per kilogram. That's direct conversion to megawatts, right? Or watts?
Yeah.
What do you know that number?
Isn't just 1,000? But that's what he's asking for. He's asking for kilojoules over kilograms.
Right, and then there's watts after that.
Oh yeah. That one's a
that's
lot.
power output. That's the next one.
Yeah. So you have to use the. I was waiting for everyone to catch up.
Right. Okay.
Yeah. So for that one's a pretty long one. You have to use a conservation of energy.
Oh, dandy. Okay.
So for this one, I'm not sure if I'm right, but correct me though. I'm not.
Okay.
So basically, I use the conservation of energy. You know, that DES dt equals Q plus WS plus that equation.
Right.
Okay, so you want to write that down?
Yeah. I mean, not really, but I will. I really don't want to freaking EM. I'm just gonna write EM for now, and we'll fill the rest. But
Okay. So that becomes 0, steady state.
right.
Q becomes negligible from order of magnitude. The work we have is shaft work from the turbine.
I should probably. I'm just gonna separate this. So
if you want to save time, we can cancel all the summations, and I'll tell you what we're left with.
Yeah, we could just automatically do summations. That's true. Yeah, we'll be left with that.
Yeah, you want to skip that part too? Just choose m dot equals hi minus ho, just to save time.
M dot equals hi minus ho.
Yeah, because you know how you can pull out the conservation mass. You want to skip that part and just go straight to that form, just to save time.
So you cancel both of these out.
Yeah.
Or you cancel both of these out.
No, I didn't cancel the velocity. We had the velocity. We just got it from the last equation.
Okay, you canceled this out though, I'm assuming.
Yeah, because negligible order of magnitude.
Okay, yeah. So mass you combine plus right.
Yeah. So basically, he gives us the mass flow rate. He gives it to us, which is 12. And so you see HI and HO. He told me to use tables for those.
Oh, really?
Yeah, that's how I got those numbers.
If I suddenly disconnect, it's because my shit died. I'm trying to plug it in.
Okay. So for those, so I don't know if you guys want to look at your own and just double check if I'm right, but I can tell you what I got for those. So HI for me equals 3,242.3. And HO equals 2,437.74.
What units are these again?
They're in enthalpy, so let me just check.
Units.
Yeah, kilograms. I'm sorry, kilojoules over kilograms.
Oh, duh. Okay, I knew that.
And then you just you have a minus sign in between those.
Right. Yeah.
And then you also got to subtract the 1.95 kilograms over kilojoules from the last equation.
1.9. Oh, because that was the total. Okay. Yeah.
Yeah, of the kinetic energy.
Yeah. So this entire thing, that's equal to kinetic energy, which we know is 1 point. Is my research working?
Yeah.
Negative 1.95 kilojoules per kilogram. That's what it was, right?
Yep.
So then that's just gonna go back there. So this is kind of insignificant then. Wait, are you sure these are in kilojoules?
Yeah, that's what it says on the table for me.
Okay, so this is pretty insignificant then, right?
I mean, yeah, I still subtracted though. He
right.
told me to.
Right. I'm just saying it doesn't seem
yeah
significant compared to these.
And then, so when you multiply everything and add everything and subtract everything, you'll be left
with this mass flow rate, by the way, right?
No, you're not supposed to. He gave that to you. It was 12. Remember?
No, actually, I didn't. I barely looked at it, to be completely honest with you.
Yeah, he gave it to you 12 kilograms over seconds.
Okay, yeah. So
you know how you see? You can look at the conversion. You'd be left with kilojoules over seconds, which equals watts. You know?
Right.
So that's when you add up everything.
All right, so
So basically for that, I got 1002.62 kilojoules over kilograms, and then times 12, which made me get 12,031. And I got 12.0 megawatts, which I'm a lot, not a lot, but I'm off by 2, which I don't know if he's going to accept that answer or not. Because this is the best I came up with at the moment. Because he told me to use tables, and I use tables.
yeah, so that's gonna be off, no matter what you do.
Yeah. So that's the best I got it to.
Yeah, I'm just doing that math real quick to double check. Not to say that you're wrong, but so, okay, wait. So you got 12,000?
Yeah, I got 12,031.32 kilojoules over seconds, and then 1 kilojoule per second equals 1,000 watts,
Wait,
and that's
kilojoules per kilogram, kilojoules per second. Yeah, I'm not getting that number. You didn't do any conversions, did you?
no.
Okay, I might let me double check.
So basically, I did was 3,242.0 minus 2437.74 minus
Right,
1.95,
right, times 12.
and I got 802
Right.
times
Mhm.
12. Huh.
And you got 9631, right?
Yeah,
Yeah, that's what I'm getting.
that's weird.
I don't know. Maybe you just messed up number somewhere the first time.
Yeah. Let me not put the.
Ooh. But you said you were pretty close with that original number you had, didn't you?
Yeah.
Ooh, okay. Well, we'll see what that does, I guess. Per second, which is watts. And we just ignore the negative sign because it's work, right?
No, you're going to get a big negative. I mean, yeah. Never mind. Yeah, just ignore it. That's what I did. I ignored it.
All right. Okay. Yeah, our numbers that number's pretty far off, isn't it?
Yeah.
Yeah.
Okay.
Because this would convert directly to kilowatts.
Wait, what number did I tell you? 30. I told you 3242, right?
Yeah, that's what I got.
Okay. Yeah. Huh.
Yeah, we need megawatts.
Yeah, you can get megawatts though if you divide by if you multiply. We're going to multiply by 1,000 at the end. That's how we get megawatts.
Megawatts and kilowatts, that's the same thing.
Yeah.
Actually, can you do kilowatts, or is kilowatts a thing, or is it always megawatts?
There's kilowatts,
So
but that's
megawatts and kilowatts are the same thing?
no, they're not. I think one's negative and one's positive. I don't know, but I know like megas in the 6 and kilos in the 3.
Okay, we are way off. Wait.
Yeah, that's what I'm saying.
Yeah.
They're not the same.
Mm-mm.
So we're off by a lot.
It seems that way.
Because he told me to leave it as H. Because he told me that steam is not an ideal gas and it's not incompressible. I mean, he told me it's compressible. That's what he told me to do. He told me to use H for those tables.
Oh wait, did you see what Delano just messaged me?
No.
Okay.
Is it?
I thought M was kilo.
Oh yeah. I forgot.
Okay, so that's not
My
too
bad.
far off.
No,
You're good. But
maybe some numbers are.
So
it's
wait, if we got 9 then, and the answer is 10, isn't that still right though?
yeah, that's not too bad because you looked up the numbers on a table, so they're not going to be extremely accurate.
Cool.
What table did you use though? I'm curious about that.
Yeah. So if you type in, go to compressed water and superheated steam table on Google.
Yeah, so superheated steam. I'm pretty sure. Yeah, superheated water. So
And then there should be like it should be like a table that says megapascals and Celsius, and they give you V, P, H, and S.
what's the pressure here again?
Let me see your screen.
I'm still sharing, right? You can see it. I thought.
Yeah, but you're sharing your board. You're not sharing your computer screen.
No, I'm not up on there. I'm looking on the one that he gave us. I'm looking on the superheated table that he
Oh
gave
no,
us on
his tables for me those were too little because they never went up to 200 Celsius. Or I mean, how much Celsius was it? It was 400.
150.
Yeah, 450. I couldn't find those on the table. They were too small that he gave us, so I had to Google it.
Okay, so you did saturated water or saturated vapor, same thing.
Yeah, so the first one was compressed water and compressed water and superheated steam. And then the second one, he told me to use a saturation for H out, which was saturation properties for steam, pressure dash pressure tables in kilopascals and megapascals.
Okay. Okay, what did you look up again exactly? If you're finding the graph for it?
You just want me to email it to you?
Yeah, sure, I guess that works. Or just send it in Discord as a link. So everyone can see it.
I don't have Discord on my computer. I'm on my phone right now.
Okay. Yeah, just screenshot it and post a picture in Discord. Then that'll work.
I got you. Okay, there goes the saturation table. That's the first one. What did he give us? 10 megapascals.
Yeah.
Okay, so let me find that table because this one goes all the way to 50 megapascals. And there goes the second table for his Steam.
Okay, so it was 10 megapascals at 450, which is 3242. Yep.
I mean, I think he should have just provided us a graph himself.
Definitely, that is true. Then 10 kilopascals with. Wait. Oh, he gave us a vapor quality too.
Yeah, no, that's why. That's why I told you. The first one's vapor quality. The outlet is vapor quality. That's saturated. That's a different graph.
Okay, I get what you're saying. That makes sense.
And so for that one, I went to megapascals and Celsius. For
Right.
we had two different temperatures for that one, correct?
For that exit? Or no, we only had temperature for the inlet.
Inlet, okay. Yeah, so for that one, I went to 10 kilopascals, which are 0.01 megapascals. And when I went to that graph for the saturated, that's the only one I saw. Which
Okay.
was the.
I don't think we're gonna worry about it honestly, because we're all gonna say that we worked in a group together. I
Yeah.
don't think it matters that we use the same numbers. So I'm thinking we'll just stick with that 9 number and be happy with it.
Yep. Okay. You ready for the next part?
Yep. So that's finding turbine inlet area. Oh, is that just conservation of mass again?
Yeah, basically.
Okay, so what was it?
So basically, he gives you the mass flow rate, the mass flow rate, which was 12, right?
Yeah.
Right.
So then I got 33.578 for the density from the saturated graph. Because you know how it's the outlet? Oh no, that's the inlet. So then I got it from this should be the superheated, which was yeah, I got from the superheated. Yep, because that's the inlet. Inlet was superheated, and you just have to multiply by 80, and just divide by whatever, and you get the answer. Can we skip B and can we go straight to C? Because that's the only one I'm missing. I could give you guys C. I mean B later.
Yeah, sure.
So you just divided this by
The 33.578 times 80 and divide that by 12, or I mean 12 divided by that number.
yeah, this is divided by velocity times the density. And then what did you say that density was that you looked up?
33.578 on the graph, on the superheated graph.
Okay.
So if you go to 450 Celsius and you go to that P value, it tells you it right there.
And I'm assuming it's kilograms per meter cubed. I think.
Yeah, they are.
Okay.
So we're done with this part. See, I have it halfway done. I'm just stuck on one part though.
Are you talking about B or C?
No, I have B. B I have. I'm gonna give it to you guys later once we find C because we're about to run out of time to turn it in.
We have 4 hours.
4 out. Well, 2.5 for me because I have to finish my physics homework.
Oh, okay.
Oh. Okay.
Yeah.
I was like, what?
I know, right? Like,
I was like, bro, this is due at midnight.
okay. Yeah. Okay. So what do you suck on with C?
So I drew the thermodynamic system. I get the conservation of energy equation. So we can skip all that. So basically, I'm at the part where it says 0 equals Q plus WS plus M dot, and in brackets HI minus HO plus 1/2 VI squared minus VO squared. And I made that. He told me that one was negligible of order of magnitude.
Okay. So let's just set that up. And
You want to?
you don't need anything from B to solve for C.
That's why I don't know. I don't know. That's the problem.
Oh.
I'm really confused about it now at the moment. Because I have Q. Q negative is negative out because he's looking for the insulation is taken out. So isn't the heat coming out from the turbine? So shouldn't that be negative? But we also have shaft work, and shaft work we gotta use from part. Oh, I have the mass flow rate from part B.
Wait, what physics are you in?
The same one you're in.
Okay, that's due tomorrow night.
Yeah. I still have to finish it though, because I haven't gotten started yet, and I also have to study for the exam tomorrow too.
Okay.
Yeah.
Yeah. So
Damn.
I'm still give you guys part B. I'm not gonna leave you guys hanging. I just want to finish part C.
Okay, just give me that equation that you just said.
Um.
So there was you had work Q.
And then plus M dot. HI minus HO. Yep.
Yep. And you had velocities too, right?
Yeah. Plus velocity squared.
You had both of them though.
Yeah. And all that equals 0.
Right.
Okay. So shaft work, I have shaft work. Right?
Yeah.
Okay. I have negative Q out. Correct?
So
Because it says, if you read it, it says the insulation around the turbine is removed for maintenance.
right.
So isn't
so
that
it loses heat?
Yeah. From part B, I found the mass flow rate, which was I got the same number. I got 4.84. And now this is where I'm stuck at. I don't know what to do for the next part.
Okay, so
Because I use tables for 900 in Fahrenheit and the vapor quality of 1 for the exit,
right.
and I was getting the thousands, not in the hundreds, the thousands.
Okay, did you not separate? Oh, you're trying to look up enthalpy, right?
Yeah. Because you can't do anything with it. Steam is an ideal gas. You can compress it.
Yeah, right.
So this is basically a case 3 for us, you know?
Yeah, that makes sense. Okay, so you found both of these though, right?
But I found them, but I don't know if they're the right numbers or wrong numbers though, and that's the problem. Because when I plugged them in, I was off by a lot.
What numbers did you have?
Hello?
What numbers did you have for these enthalpies?
79,000.
For
No. Oh, enthalpies. I'm sorry. No. Okay, so for HI was at, let me see what's that in Celsius. 900. So it was 480 Celsius. So I got for that was the table um at 5 PS no. So that's 1,000 PSI. So PSI to megapascals. Let's see what that is. That's 0.062. It's all the way at the top. So for that, I got 3,446.6.
that again?
3,446.6.
Okay.
And then for that one, so that one should be, convert that one to 1,000. So let's do 5. Yes,
And that was 1,000 psia, right? Psi atmospheric
oh shit.
or absolute.
You said 1,000. Never mind. That should be 6.8, not 0.06. Give me 1 second. Fuck. Okay, so for that one, I got about 3,362 for HI. I'm sorry, I gave the wrong one. 3,362.6. And then for this one, just put 5. It was 5 PSIA. So that one's 0.03. But that one should be
And this is in BTUs per. What is this in? What unit is this?
kilojoules over kilograms.
Okay, never mind.
Okay, so and then for the HO, it should be 2335.2.
Wait, how did you find HI without temperature?
I looked at the chart, and I went straight to
Oh, vapor quality. Yeah.
yeah.
Okay. Who keeps on leaving and joining?
I don't know. So now for velocity. So you see how in part B he says to cancel out velocity to cancel it.
Part B3, you're saying?
Yeah. So you see how he says the pipes have also retrofitted to minimize any K difference. So that means it's negligible by design, basically.
Okay.
So should I do the same thing for this one? Because he doesn't tell me. That's the problem. That's the problem I'm having. Or should I use the 50 ms and the 80 ms for velocity? That's what I was confused about.
Yeah, I see what you're saying.
And because he gives us work, that's
Right, that's the 4 megawatts.
yes. So you see, I don't know what to do after this then, because everything I plugged in, it was wrong.
Okay, so the final answer is 182 BT per second. Yeah, I'm checking. Then the mass flow rate's still 12, right? We know that. So
Yeah. No, the mass flow rate.
yes.
So you see on part B the answer, right?
Okay, so you do need that from part B.
Yeah. That's what I used for mass flow rate. That's what I assumed I used. So since I used that mass flow rate, I didn't know if I should cancel out velocity. Still.
Oh. During an Yeah, well, no. Because they're different situations. The power... that is weird. I would just... And you tried canceling out... You tried canceling out velocity and solving, but still couldn't get it?
Yeah, if you want to try it together and see if I messed up somewhere, and then see if we get the right answer.
Yeah, we'll try.
But I just been working on it for 2 hours at school, and then I couldn't figure out anything, so I just gave up.
Yeah. So this is... What is that? 4,000 kilowatts?
Mm-hmm.
Or kilojoules, I mean. So...
Oh, that Q would also be I moved it to the right side, which will make it positive.
Right.
Left side. I'm sorry.
Yeah, I know what you mean. Okay, we'll pretend like that doesn't exist. Wait, can I do this? Great. What the hell?
For 2B, do you use conservation of mass for the exit area?
Yeah.
Okay,
Yeah.
thanks.
Okay, so this is going to be... I think all the units line up, too, because you have kilograms per second multiplied.
Yeah.
And we're assuming this isn't here right now.
Mm-hmm.
So kilojoules, kilograms.
And you should get watts.
Yeah, which is joules per second or kilojoules per second.
Yeah.
Oh, and this was per second. I forgot that. Yeah, so all those units line up.
Let's do this then. Q equals. So basically, shaft work we could turn that into. That's basically kilojoules over seconds, right?
Shaft work is kilojoules per second. Yeah.
So if we have that. Oh, so if we convert that to wattage, we could go from BTU to hours.
If we convert the wattage, we could go to BTU hours. I mean, we already converted the wattage to joules, and we're doing joules. Wait, so 1470. I'm trying something right now. 182. Do we know his answer is correct? Have we heard any situations where his answer is wrong? Or any cases in which his answer is wrong?
He checked it. He checked it when he got the one wrong. He told me it was right.
Okay. Just double checking. So what I'm assuming this is what you did, but you just took that 4,000 kilojoules per second, and then this is actually negative because it's leaving the system, by the way. So that doesn't really affect the final answer, though. I mean, it does affect the final answer, but it's still off. The 4.8523362.6 minus. And then that's like, I got 1,470. Is that what you're getting?
Let me see.
That's kilojoules per second. Minus that 4,000.
I got 5,470 for that part.
Yeah, and then you need to subtract 4,000.
Yeah, minus.
So that's that 1,470.
1,470. Yeah, and then so that's kilojoules, or that's
Right.
yeah. So that's kiloseconds over kilojoules over kiloseconds.
Yeah, kilojoules to BTU, that it's still not right. It gives you like 1,393 BTU.
Times 0.947813. Yeah, which is giving me 1,393. That's what I got.
Yeah, that's what I'm getting to, which is not our 182, obviously.
Yeah. And if you add in velocity, it's just going to make it a bigger number.
Yep.
Did you try that? Let's try that 12 instead of 4.8.
All right.
Then again, if we do try 12, it's still going to be a bigger number.
That is true. We'll see if numbers match up, though. So 2 times 12.
No.
Yeah, that gives you like
9.
958. Yeah.
Yeah, 0.8. That's even a bigger number.
I mean, unless the exit velocity is much greater, but it should not be.
Let's try that then. Yeah, isn't that negative though?
Yeah,
Let's see. So 0.5 times. It was
no,
50.
the inlet was 80 meters per second and the outlet was 50 meters per second. So it's going to be a positive number. Let's go through B real quick, because I haven't gone through B yet. That might help us for C, because I'm not seeing anything we can do.
Give me 1 second. Yep, then I'm just getting 555 for that one. If I add the which is closer.
That's really how did you get a smaller number? You're saying when you added the velocities, you got a smaller number?
Yeah, because the velocity is negative.
How's the velocity negative?
Because your V in is 50 and your V out.
Your V
never
is
mind.
80.
Yeah, never mind. I had it flipped. That's why. Never mind. Okay. I guess we go straight to B.
Yeah, I'm hoping we'll see something there to help us for C, because I'm seeing the same issue with C that you were.
So I did the same thing for C. You know what we just did for C? I did the same thing. Just type in what you have. So the velocity is 0. The magnitude, the G is negligible to magnitude. Look up your HI and your HO in tables. That's what I did.
Okay, and you did end up getting the right answer?
Yeah.
Okay, wait, so during the downtime when the demand is lower. That is the exact same question.
Yep.
Okay, I see.
So basically here, you basically do 5 MW, and I can give you my HI, which is 3375.1 minus 2342.1.
What was it?
3237.1. That was for the first part.
Okay.
The first one is 3237.1 minus 2342. 42.1.
Yeah.
And then you have that m at the end,
Right.
And then once you bring that 5 out to the other side and just divide, and that's what you get.
What 5 are you talking? Oh, was that something he gave you?
Yeah.
Yeah, that 5 megawatts. Okay.
I get negative, but you know how mass can't be negative, so I just switched to a positive.
Right. Yeah, that makes sense. And that's negative as well, right?
Yeah, and that's how I got the 4.
Okay. Yeah, that's pretty easy. And then
I just did the unit conversions and stuff.
yeah, OOM. That's what it would be. Did you have to do unit conversions? I don't even
No,
think you would need
I don't
to.
think so. But I just gave it to her just to make her happy.
That is. Yep, you should do that.
So back to C.
Yeah.
Okay. So I'm guessing the velocity is canceled, right?
Yeah, I think they would have to.
Because there's no way he doesn't give us velocity, and if we use that, we're going to get a bigger number. So that goes bye-bye. Let's make that negligible by design. By design. Cool. So we're basically left with the same things from last time.
I forgot. Yeah, okay. I was just looking at this. Q, that's negligible again because they didn't take that insulation off, so that's gone. I'm just noticing this. I'm sorry.
No, that's okay.
But how far are you guys going into homework? I assume that's what you're doing.
Yeah. Most of it. We are stuck on 3C right now.
Oh, okay.
How did you get that 4-point number for B?
Me?
Yeah, I'm getting 5.5.
So if we do 5,000, that's what you have, right? 5,000
Yeah.
divided by 3. Well, I put in parentheses. 327.1 minus 2342.1. Yeah, I'm getting that to Y. Let me see this then. Why is that?
Hate how he changes units so goddamn.
Oh, yeah, no, yeah, the right answer was 5.58. That's what I got.
Yeah.
And I left it like that because it was close enough to 5. Because I did everything right. I canceled everything that was supposed to be canceled. So I thought it was an error on his end.
So
Assuming that means the error is probably on his. That's probably his fault too. On the C.
maybe. So okay, wait. What was the pressure at this H out for number or for B?
H out.
Yeah.
3242.1.
Oh, I meant C. I'm sorry. Oh wait, 3242.
No, not 32. I'm sorry. I meant 2342.
Yeah. What could you using that vapor quality that he gave you? Could you find a pressure for it?
Yeah.
Okay, what would that pressure be? Because I'm just using an online calculator right now, and I'm just typing in temperature, pressure, and I'm seeing if we get a little bit closer to that 4.8 number.
He gives you the pressure though. Just let me find the paper.
He gave us the pressure for the inlet. For the outlet, he just said it was 10 kilopascals and it was a 0.9 vapor quality.
No, the inlet was 10 megapascals. The outlet pressure is 10 pascals.
Right, and the inlet temperature is 500 degrees Celsius. We don't know the outlet temperature. We just know that the exit vapor quality 0.9.
Yeah, so I used the vapor quality for the outlet, the 0.9. And I used kilopascals.
Okay, and you looked that up on the table, right?
Yes.
So what is the pressure that's associated with 10 kilopascals and a 0.9 vapor quality?
That's 0.01 megapascals. That's what I use for the table. Because the table show only pressure only.
Yeah, I'm sorry. I meant temperature.
Oh, temperature. Temperature that should be 69 Celsius.
69 degrees Celsius.
Yeah. Well, 69.1.
Okay.
No, I'm sorry. Yeah, not
that's
60.
Definitely not.
No, for that one, it's 45.81. That's what I got for that one. Celsius.
35.81.
45.
45 point. Okay. So it's 2583. So try those numbers and see if we get closer to the
2583.
Yeah, because I just use an online calculator, and I just want to make sure that that's human error, not anything else.
Okay. 4,000.
Okay, that's even more off. Jeez.
32. You had 33. 75 minus 2583.
Yeah, it's even more off. So
Yeah. I'm just leave what I have.
yeah.
It's the closest.
Right. I was just hoping that would be a little closer. Oh well, but
And for part C, I'm gonna do the same for part C. I'm gonna just leave in the thousands instead of the hundreds. There's not much I can do about that.
it's so weird though.
because he doesn't tell us if velocity cancels. He doesn't tell us that, like in part B.
Right.
And if he doesn't tell us to use what mass flow rate, we have two. He doesn't tell us which one to use.
I hate this thing. It is not working. Okay, let's try. Okay, fuck that. Yeah, I mean, that seems pretty far off, though, if we're assuming his answer is correct.
I mean, I was assuming it because he double checked everything, but
yeah, let me read through that again. So
1, 2, 3. Okay, there we go. Did you catch anything?
no, I mean, yeah, we're doing the right conversions, right? From like joules to BTUs. It's just that.
Yeah,
Not
it's
a huge difference.
Yeah, it's almost 1. It's 0.9. It's 0.945 something.
Yeah, and that's definitely for kilojoules, right? I just want to.
Yeah.
I want to double check everything.
Yeah. You can double check it.
Yeah, it is. Shoot.
There's literally nothing I did wrong. I mean, the only thing I can think of is the graphs I'm using, but we've been using these the whole time.
Right. I'm thinking we know velocity isn't part of it at this point.
Yep.
Yeah, I don't know why the heck this isn't freaking working.
I mean, then again, he did forget to give us the information for 2B. Like all of it.
Yeah, that's true. I don't know. Can anyone think of anything?
What do you use to find mass flow rate in 2B?
2B?
Yeah.
Just give me 1 second.
So, I scribbled out that 2 number.
So basically, for mass flow rate, you know how you have that 0.528?
What? From where?
Oh no, that's what you're looking for. I'm sorry. Mass flow
Oh,
rate.
yeah.
So, 2B. Let's see what 2B says. So you're going to use a conservation of mass, and once you break that down, m dot will equal everything in.
Oh, in? Oh, okay.
Yeah, is equal to m dot.
Oh, okay, yeah, that makes sense. Alright, and that's it? You just plug in the values? That seems easy.
Yeah, just plug in the values. And density we used for that one was 2.2.
Oh, why?
That's what the table said.
Oh, okay. Alright, thanks.
Yep, you're welcome. Uh, hey Reese.
Yeah.
I'm about to bounce. Um, so you want to put your name on here as a group?
Yeah, sure. Just throw it. Just take a picture of everybody here.
Did anyone record this or anything? Because,
I did actually, yeah.
okay, can you post a recording or email it to me or something?
Oh,
'Cause
it's gonna be a really big file size, and it's probably gonna take a while to upload, but yeah, I'll start doing that right away.
Okay, thanks.
I have everything written down for starting at 2B.
For number 2B, did you have to use PV equals MRT?
No, actually. So you can see my screen, right?
Yeah.
So I thought it was going to be PV equals NRT too, but Andrew was talking to Cobus during his office hours, and apparently this density is constant. You don't have to change it for each pressure, so you could just use this value for that density.
Okay. Well
No.
then,
Cobus didn't
that,
tell me for that one. Not for that
that
one.
erases half of my page.
I know, right? That's what happened to me too. What do you mean he didn't tell you for that one?
He just said it looks okay. He didn't tell me that.
Okay, well we're assuming that means it looks good, and we got the right answer. So
Okay, so just call density
yeah, just
1.2 kilogram per meter cube.
Yeah.
And how did you get mass flow rate out of it? Because I have enough stuff to get temperature, but I don't know how to go from there.
That's you're just gonna do a completely separate conservation of mass equation with the. So do you have? Yeah, you don't have mass flow rate or area. You have the right temperature though, right? At this point.
I haven't calculated it yet. I have all the information that I need to get it.
Okay, so this is just conservation of mass.
That's velocity.
Yeah, so we have both velocities, and you could look up the densities. Once you find the temperature, you could look up the temperature at that pressure. Because he gives you the pressure, and once you calculate the temperature, you could find the density of the final one.
Okay.
So that'll mean you'll have this density. You already have this velocity.
I think basically if you post the notes, I should be able to follow from there. Go ahead and add my name to your stuff, and I'll add up. I'll just say at the top of mine, in communication with most of the class.
I've just been like taking a picture of the chat and writing down everybody's names. But yeah.
For the exit area, are the densities different?
For the exit area, are the densities different? Yeah. Yep.
Oh, how do you find those?
For the initial one, we know that what was initial temperature?
Uh, 473.1 Kelvin.
Okay.
So that'd
Yeah,
be 200 Celsius.
Okay,
Yeah.
so where is it?
Yeah, I started a little bit after you guys, so I was never able to actually join in the conversation.
Yeah, same. I've just been catching up this whole time.
Yeah, sorry. Wait, 200 Celsius?
Yeah.
Yeah.
We're doing 2B, right?
Yes.
He emailed it to you. Remember? He messed up on it.
Oh yeah, I'm a dumbass. Okay. Okay, so yeah, you know 200 degrees Celsius, and you know what was it, like 300 pascals, right? Or 300 kilopascals?
Yeah.
Yeah. And then just look up density at those values.
Yeah, and you could do the same thing with this density at the 100 kPa, and you'll calculate that other temperature with this, which is like 188.
Okay.
And then you could get area and mass flow rate from that.
All right. Thanks.
So yeah, if you could post that, and if you can get the recording up in time, and post that.
I didn't record.
Yeah, Zach said he recorded it.
Okay.
Yeah. As soon as I finish up these last two, I'm almost done. I'll start uploading.
Okay, that's fine. I think the notes should be good enough for me, though.
Yeah, I'm sure I can post this somehow. I haven't posted a whiteboard before, but I'll figure it out.
Screenshots.
Yeah, that'll work. Did any